Hello, my name is Mohamed Zain, and in this video I will be explaining about my design for my EV311 individual assignment. In this assignment, we have to analyze and prepare a video recording on a water treatment technology based activity. We have to conduct tests on the water from the device we have constructed, and we have to provide a reflection on the results obtained from our water treatment device. The topic I have chosen to design my water treatment technology is water treatment process. Water treatment process involves 6 stages or 6 steps. Step number 1 is aeration, which is bringing air and other gases in contact with the wastewater. Step 2 is coagulation, which is adding chemicals to water that can increase the force of attraction between the suspended solid particles within the wastewater. Step 3 is percolation, which is mixing and agitation of coagulated water to increase the collision between particles to form flocks, which will stick together and after becoming bigger in size will sink to the bottom. Step 3 is sedimentation, which is removing solid particles heavier than water using gravity. Sedimentation will be done with low flow and minimal turbulence so that denser particles have enough time to sink to the bottom. Step number 5 is filtration, which is removing of the fine suspended solid particles that cannot be removed during the sedimentation process. The final and last step is disinfection, which is done to destroy the pathogens present in the water and make it safe for consumption. My outcome for the project is to see if I can improve the quality of wastewater by using a DIY water treatment device at home. I will be using 2 types of tests to confirm this. The testing will be done with 2 testing devices, which is a TDS EC meter and a pH meter. The TDS and EC meter will measure the turbidity and electrical conductivity of the sample, and the pH meter will measure the pH of the sample. So for my design, based on the types of testing that I can do at home and the materials I have available, only 4 of the mentioned water treatment processes which I mentioned previously will be included in my design, which is coagulation and percolation together, and sedimentation, and then filtration using a charcoal, pebble and sand filter. I will not be including aeration and disinfection in my design because I have no way of measuring the BOD level for aeration at home, or I cannot measure pathogens present in the wastewater sample, so I will not be designing for disinfection. The design for the water treatment device will have a three-staged water treatment system. Stage 1 will be coagulation and flocculation, and it will have a water pump installed to help with the flocculation process. Stage 2 will be sedimentation, and it will have a low flow to the next jar to allow for flocks to settle. Stage 3 will be for filtration. It will have a charcoal, sand, and stone filter, and the device will use gravitational flow to pass water from one level to another. To make the device, step number 1 is to prepare the jar for flow of water by drilling a hole on top and putting a PET with hot glue so that PE tubing can be connected to it. Step 2 will be to prepare the frame with 3 levels using the mini PVC trunking. You can cut pieces of the PVC trunking and stick it together with hot glue to make the frame, and cut a piece of styrofoam to make a base for the jar to rest. Step 3 will be to install the immersible pump in the jar 1 using hot glue. Step 4 will be to make the filtering jar. To make the filtering jar, you put in the filter paper first. Next, you put in the fine sand, followed by the 2 sizes river stones, and lastly, you put in the charcoal. For testing, as I mentioned previously, I'll be using 2 devices, which is a TDS EC meter and a pH meter, and I'll be measuring 4 parameters using the devices. They are the temperature, the turbidity in parts per million, the electrical conductivity in microsiemens per centimeter, and the pH level. To carry out the testing, I use 2 main samples. Sample 1 is distilled water, which will act as a control and as a reference as the best quality of water. Sample 2 is the wastewater I prepared using random items from the kitchen mixed together. I added some dish soap for alkalinity, some tea leaves for big solid particles, and some cocoa powder for fine particles and to give some color to the wastewater. The wastewater was further tested in 4 conditions after using the water treatment device. Condition 1 is using only the water treatment device without any alum. Condition 2 is with 3 grams alum added. Condition 3 is with 4 grams alum added. And the last one is with 6 grams alum added. The results I obtained are shown in the table. As for my final thoughts on this project, using the proposed method of 3-staged water treatment device along with alum mixed into the wastewater, it was able to make the water cleaner visually. However, the measured parameters, which was the turbidity, electrical conductivity, and pH of the tested samples, were not improved compared to the control, which was the distilled water. In my opinion, here are some of the reasons that could have contributed to these results. One is the reduced sedimentation time. It was observed that after treating with the water treatment device and leaving it for a few hours, the finer particles or the sediments were able to settle better and make the water even clearer than when it was initially filtered. So if the flow from the sedimentation level is reduced even further and the particles are given even more time to settle, it will help to improve the quality of the water. Also, the sedimentation of the device can be redesigned in such a way that only the top portion of the water is transferred from the sedimentation level to the filtration level, so that the sediments at the bottom will remain without being mixed with the filtered water. Due to this design flaws in the sedimentation level of the device, some of the sediment particles formed were passed along from the sedimentation level, which contributed to the increased turbidity of the treated water. Another factor that could have affected the results is the increased LM dosage. The optimum LM dosage is around 0.025 grams per liter. However, from the scale that I had available, I could only measure up to lowest level of 1 gram, so I was not able to use the optimum level. Due to this, the increased LM dosage concentration in the solution may have contributed to increased turbidity and electrical conductivity of the treated water sample. To correct this in a redesign, a more accurate scale can be used to measure precise amounts of LM up to 0.025 grams per liter, and further testing should be done on limits within that range. Another factor that could have affected the results is using powdered charcoal. The powdered charcoal added even more finer particles that was not properly removed by the filter. This may again have contributed to increase in turbidity and also made the treated water slightly more acidic along with the excess LM already present. This can be observed in the results obtained. The solution for this could be to use granulated charcoal instead of powdered charcoal, so that it can still filter the water without increasing the turbidity. The last factor that could have affected the results is the filter paper size. The filter paper used was not sufficient to remove the very fine particles in this experiment. The size used in the experiment was 10 to 12 micrometer. The pore size was enough to remove the bigger particles in the water, which was able to give the treated water a clearer appearance visually. However, it was unable to remove the very fine particles that contributed to the increased turbidity and EC values. A correction for this would be to use even finer filter paper with smaller pore size. That is all for the design of my water treatment device. Hope the video was informative, enjoyable, and you were able to understand something new from the information I have shared. Thank you.